Hi friends, welcome to the Unit 5 Day 2 notes. These notes are on solving linear systems in 3 variables and then also including some applications or some word problems. First we're going to start with taking it back a bit. When we have 3 variables, that's 3 dimensions. So before we get there, first let's talk about just, when we have a single variable, so x minus 3 equals 4, well this is just a point on the number line. So this is just 7. So if I think about this on a number line, so what I'm going to do, if I start with a value and I subtract 3, I get to 4. So the opposite of that is then you're adding 3 to get from 4 to get to 7. So that's just a point on the number line. That's it. So that's a point on a 2-dimensional space. So when we find a solution to variables on the XY grid, we call that a 2-dimensional graph. That's what we did in the last section in Unit 5 Day 1, where we're finding where 2 lines intersected. So we had to use this 2-dimensional space, and then we had basically lines, so using the number line, in a 2-dimensional space to find out where things intersected. So there's an example of that. So 3 dimensions, we call that an ordered triple, X, Y, Z. The result is a plane in space. This is called a plane. Now we can end up with a solution set that is a plane. In 3 dimensions, the XY plane is parallel to the ground with the vertical axis named the Z-axis. So think about how far you go up or down is the Z-axis. X is coming towards you or going away from you, and then Y is going to your left and right. That's the easiest way to think about that. So example 1, we're just going to visualize something in 3 dimensions. Here's your 3-dimensional plane. So this is 0, 0, 1, 2, 3, 4, 5. This is your Z, so that's how much you're going up and down. This x-axis is how far close it's coming to you, and then y is going left or right. This one's just showing to the right. Imagine this is in the bottom left-hand corner of your room. So that's a good way of thinking about it. Bottom left-hand corner. So if you can visualize, actually look in your room right now. Look in the bottom left-hand corner. That's where this is in this example. So we need to find 4 additional points on this plane. So we want it to equal 3. So if I think about this particular type of problem, I can go 1 out, and 1 out, and that would equal 3. So if I have this as an example, this would be the order triple 1, 1, 1. That would make this true. I could also have, say I went 2 out on my x, 1 out on my y, but then I didn't go up at all. That would also be true. Similarly, I could go out 3 on my x, none on my y, and none on my z. That would also be true. I could also do 0, 1, and 2. So far you see that all of these, they have to add up. These have to add up to be 4. I could create a very long list of this. Notice I just picked integers. I could pick rational numbers. I could pick negatives even. I could start throwing in some negative numbers and get that also, and that would also be. So what happens is we create a plane that makes this true. If I collected all these points together, it would be a plane. So if you think about it, it would be like a sort of kind of like intersecting kind of flat sheet of, if you think about like a flat sheet of paper, it'd be like a flat sheet of paper. So if you think about it in your room, you just have to meet this criteria that would be like a flat sheet of paper that would be coming out kind of at an angle from that. So how can you determine if the points you found are on the plane of x plus y plus z equals 5? Well, they would add up. The values of each point would sum to be 5. So it would be on that plane. So here's a visual representation. So here what we have is we could have these planes are intersecting, and they could intersect to form infinite solutions to make a line. So this is an example where they form an infinite solutions because it creates a line. So we call this, where it's infinite solutions, going back to our previous section, where we talked about consistent, independent, coinciding, and then a dependent system. So this one would be a dependent. One solution is independent. and then no solutions is inconsistent. I started writing inconsistent on this line down here. Those are the different types of solutions. Remember, these two, dependent, independent, we call them, they are both in a consistent, because they have at least one solution. So those are consistent systems. In my next video, I'm going to jump into determining if these are ordered triples, but it's just checking, plugging them in and checking. It's a lot of tedious work just to check. So join me in the next video as we go over this part.